What is the rate law? Okay, rate is the speed of the reaction. How do we measure it? By monitoring the change of any of the reactants or products. So we can monitor the change of any reactant or product to get the rate. So it's how fast it's changing. And then what's the right side of the rate law tell me? Okay, what's K? That's the rate constant. Is it ever change? When would it change? Temperature. Okay, it's temperature dependent. So the rate constant will change with temperature. And then, do we put products on this side?
No.
Okay, we only put reactants and catalysts if they're present on the right side of this. We do not put products on that side. Okay, what are these exponents? Those are called the order of reaction. The speed of the reaction as a function of the reactants is not always linear. What if the exponent happens to be 0? What's anything raised to a 0 power? 1. So if n was a 0, would the speed of the reaction depend at all on A? Nope, because A would drop out. This would become 1. So if we say something 0 order, that means the rate is independent of that reactant. So it doesn't matter what the reactant is, the rate just keeps going at the same rate. Okay. What if the n is a 1? What do we call that? We call that first order, and in that case, the speed of the reaction has a linear relationship, direct proportion with that reactant. What if it's a 2? Then that's second order, and in that case, it would be a quadratic. The speed of the reaction would depend on the square of the reactant. Now, for third, anything above second order, we don't really deal with. Now, if there's more than one reactant, what is the overall order of the reaction? Yeah, you add the exponents together for the overall order of reaction. Okay. Now, there's two ways. Now, do the exponents, do the orders have anything to do with the stoichiometry, the stoichiometric ratios? No. Independent. There's only one way to find those exponents. And how do you do it? By experiment. And there's basically two methods two experimental approaches you can take. One of them is called the what? Initial rate method. That's what you're going to do on Tuesday and Thursday in the lab. We're using the initial rate method. That's like the Webassign problem that we just looked at, where you have two reactants and you run an experiment, and then you change one of them, keep the other the same, and then change the other one. Okay, what's the other experimental method called? Okay, graphical method using integrated rate laws. We're going to start talking about that today. And in fact, next week, whenever you're not doing the wet lab, you're going to be doing a dry lab. A dry lab is where you don't collect the data, we'll give you the data, and then you do calculations with it. So you will be determining a rate law using the second experimental approach. You're just not going to collect the data. And so we'll start talking about how to do that today. Okay. So back to the P1, back to your lab. Big picture, experimentally determining a rate law. Now, is it important in the abstract or the summary to state what the chemical reaction is? Is that a detail that's worth mentioning? Think people might want to know what the reactants are? Sure. Okay, so what are the reactants? Acetone and iodine. Is that all? The whole thing is aqueous. Everything is in water. Is there any other reagents used? Hydrochloric acid, what role does that have? Is it a reactant? What is the HCl? Catalyst. Okay. So the HCl is a catalyst. So what would the generic rate law look like? Okay. Okay. Okay, remember that the catalyst goes in there as well. Okay, the catalyst goes in there as well. Even though it's not a reactant, it goes in the rate law. So you have three things to find the order of. So at a minimum, how many experiments will that take? If you do it the way the WebAssign problem is set up. First experiment is your baseline. And how many of these variables do you want to change at one time? One. So a second experiment would maybe have acetone changing. Third experiment, maybe iodine. Fourth experiment, HCl. So the first four experiments that you're going to run are to determine the order. And that's the bulk of the lab. Now, there's one other minor objective here. After you determine the order of the reaction and determine what K is, what are you going to do with all that? What's the fifth reaction for? There's 5 reactions. Right, you're going to just mix things together in some random order, and you're going to use your rate law to predict the time. So you'll use your rate law to calculate the expected time of that last reaction, and then you can compare to what you actually observed. Okay, so in the big picture, the primary objective is determining the rate law of this reaction, and then the secondary objective is to use the rate law to calculate or predict the expected time for a fifth reaction. And the reactants are acetone and iodine. HCl is a catalyst. There's one other detail that you should include in your summary, and that is this part of the rate law. How are we calculating the speed of the reaction? What's it based on? Because remember, you have your choice. What did we say last time? When you're choosing what to base rate on, you can use any reactant or any product. We typically choose what? Say again? Well, why would we choose iodine in this one? It's the easiest, right? What color is acetone? It's colorless, right?